Good morning, students.
Good morning, sir.
How are you all today?
Fine, thank you, sir.
How was your weekend?
Very boring,
It
sir.
was good,
Okay.
kinda, not that. Oh, it was good. I had my days.
Oh, how
So
was
we
it?
studied
It was
physics.
very good.
Okay.
Yeah.
So you guys been studying physics?
Yes, sir.
Kinda.
Okay, just a reminder that next week will be your term exam. So make sure you keep on studying it. The paper will begin from Friday. So this will be your last chapter. This will be covered in your exam, and then afterwards we'll have revision next week, and then from there your term and exam will begin. So today's topic is on electrostatics, stand 4. The lesson objective is to describe charges properties, discuss how electric force work, and discuss the superposition of principle of electric force. And lastly, you should understand all the equations that is involved. I think 3 to 4 equations, and then and also the constants that are there. So we'll begin. Firstly, we'll begin a recap from what is a charge. So a charge is an electric charge. It has a polarity that is either positive or negative. Like charges repel each other and opposite charges attract. This is just a recap from your previous years, from year 11 and 12. So there are two types of charges. One is positive and one is negative. An electric charge is conserved. It cannot be created nor destroyed. So as you all know, any charges or any energy, it is neither destroyed or created. It either changes form or moves from one place to the
another.
other. Can you read the last one, Isaac?
An electric charge is quantized. That is, electric charges exist as discrete packets, and we can write Q is equal to NE.
Okay. So this equation here, Q is equals to capital N E. This is known as charge. This is N is known as number of
Charges.
And your E,
Electron.
pardon?
Electron charge.
Okay. This is known as electron charge. Now we're coming with a big tough recap. As I've said earlier, we have two types of charges. One is positive and one is negative. So positive and negative charges, they attract because they have different field lines. For example, a positive charge, it will,
Outwards.
what will happen to the positive charge, the field lines?
Outward.
Outwards, right? And what will happen to the negative charge?
Inward.
Inwards.
Inwards. Good. So, what will happen if you have a positive and a negative, a positive and a positive charge together?
It will go inwards, both.
It will go,
Outwards, sorry, sir.
okay, yes, outwards. So between this region, you can see they are both are going outwards. They are not attracting each other. So it means this will repel. Okay. So that was just a bit of a recap from your previous level. Now we'll go on to the next electric field. What is Coulomb's law? Just a brief history. Charles Coulomb He was born in 1736 and was rest in peace at 1806. Measured the magnitude. If this is his picture, he measured the magnitude of electric force between charged objects using the tension balance which he invented. From his experiment, we generalize the following properties of electric forces between two charged particles, which is the positive and negative. What is an electric force? So there are 4 points here. I will just briefly describe it in a shorter form. So we see as point 1, it says, can someone read it?
Inversely proportional to the squares of the separation distance, that is d, between the particles and directed along the line joining them.
Okay. Firstly, we will just skip this part and move on to the equation of the Coulomb's law. So this is the force with charges and magnitudes. Q1, Q2 separated by a distance is given by the Coulomb's law. Fe is equals to Ke, Q1, Q2 divided by T squared. Fe is equals to Ke, Q1, Q2 over
D squared.
T squared. Okay, now back to this. Inversely proportional to the square of the separation distance d between the particles and directed along the lines. So that means that Fe is inversely proportional to T squared. Then this, can somebody read the point number 2, please?
Proportional to the product of the charges Q1 and Q2 over 2 particles.
Yes, so it means that the force is proportional to the charges, which is Q1 and Q2. Can somebody read the point number 3, please?
Attractive if the charges are of opposite sign, and repulsive if the charges have the same sign.
Okay, so that point means that about the charges, the positive and the negative. If there is a positive and a negative charge, they will attract. And if there is a negative charge, they will
Repel.
repel. And if there is a positive and a positive charge,
Also repels.
they will also repel. So that's it. And the point number 4, it says that the electric force is a conservative force. Okay. This slides, it discussed, we've already discussed 4.2, equation number 4.2, which is F equals to Ke over, Ke is multiplied by Q1 over Q2 divided by D squared. And then here there is a breakdown where Ke is a constant called Coulomb's constant. It is the SI unit of the charge coulomb C. So the charge is, the SI unit is C. The Coulomb constant Ke in SI unit has the value of, so in this equation, the value for this Ke is 8.99 times 10 to the power of 9
Newton
Newton
meter squared
per
Coulomb squared.
Coulomb squared. So this is your Ke value. So there is also a formula given there, which is, this is your formula 1, Ke, and there is Ke is equals to 1 over 4 pi epsilon naught. This is known as epsilon naught. So the epsilon naught, it is also a
Constant.
constant, where the constant is known as the primitive of free space and has a value of 8.54 times 10 to the power of negative 12 coulomb square nano
Coulomb
square
square
nano.
per
Okay, wait.
54
8.54
10 to the power
times 10 to the power of negative 12
Coulomb square.
coulomb square
per
Newton
meter square.
meter square. So this is just a breakdown, but so once you substitute this value in place of epsilon naught and you press in the calculator 1 divided by 4 pi times this value, you'll get this value. So from this value you substitute in the electric force formula, then you can calculate your electric force. So this is the extension ratio. Okay, now we will move on to the example that is on the physics textbook, page number 90, the example number 1. Can someone read the example question, please? Isaac?
The electron and proton of a hydrogen atom are separated by a distance of approximately 4.3 times 10 to the power negative 11 meters.
Okay, so we'll go step by step. So there is a what? Electron and a proton of
Proton.
hydrogen atom and separated by the distance approximately 4.3 times 10 to the power of negative 11 meters. So we know the distance is given as
4.3
4.3 times
10 to the power negative 11 meters.
10 to power times 10 to the power of negative 11
Meters.
meters. So it's in meters, so we don't have to change it. And then read on.
Find the magnitude of electric force and gravitational force between the two particles.
Okay, so notice that you have to find two things. One is the magnitude of the electric force and the other one is gravitational force between the two particles. So we have a proton and electron. Your Q1 and Q2, which is equals to,
1
what is your proton and electron charge?
1.6
1.6
times 10 to the power of negative 19
10 to the power of negative 19
coulomb
coulomb. Good.
plus minus.
Plus and minus, yes, because proton and electron are two different. So one is positive and one is negative. So graphically there is a two charge here, charge 1, charge 2 and at a distance Q1, Q2, and the distance between them is
D.
D. Your D is this. So we'll use this formula to find your electric force. So Fe is equals to Ke. What's your Ke?
8.99 times
Good.
10 to the power 9.
So 8.99 times 10 to the power of 9.
9.
And your charge? One is
1 positive 1.6.
1.6 times 10 to the power of negative 19, and the other one will be
Negative
negative
1.6.
1.6 times 10 to the power of negative 19 divided by D. What's your D?
4.3 times 10 to the power negative 11
4.3
squared.
times 10 to the power of negative 11
Squared.
Am I missing something?
No, sir. Oh, sir, you wrote cubed. It should be squared.
Oh, sorry. My error. There is something else I am missing from the equation.
Hmm.
The absolute sign.
Oh.
Oh, yes, sir.
There is an absolute sign between these two charges because electric field cannot be negative. So once you multiply these two values, it will give you a negative charge. So you have to take that absolute value of those two, then divide it by 4.3 and multiply it by 9.88. So do it in your calculator and give me the answer.
One
Yes.
point two four
1.24
10 to the power of
times 10 to the power of
-7. -7
-7. And what will
Newton, sir.
okay, Newton. Good. So will this attract or repel?
So, I think
So
attract.
attract.
That's good. It
Because
will?
we have one negative charge and one positive charge.
Yes. So you have
One
one
proton and
negative
one-
charge and one positive charge. So it will attract. Now this is just the part 1 of the question. There is another part 2. You have to find the
Gravitational
force. Both the charges attract each other with same magnitude but opposite direction because they are oppositely charged. Using Newton's law of universal gravitation, that was in chapter 1 I think, we find the magnitude of the gravitational force. So we know that the mass of an electron is
9 point.
yes, mass of an electron, mass of the proton. Then we use the Newton's law of gravitational formula. So what is that formula?
Force equals
Force equals
mass of electron,
mass of electron, ME,
mass of proton,
mass of proton, LE, MP,
and distance squared.
divided by
squared.
or
Divide by r squared.
divided by R squared.
Say,
Are you missing something?
yeah, I think she missed the gravitational constant.
That's G, right?
Yeah.
Okay, just G times ME times MP over R squared. Now I'm correct?
Yes, sir.
Yes,
Okay.
sir.
So what is your mass of proton and mass of electron? That's on the page 1 of your textbook. The constant table.
Mass of the electron is 9.1
9.1 times
10 to the power of -31.
negative 31.
Yeah.
And mass of proton? Liza?
1.67
1.67
times 10 to the power -27
27 in units?
kg.
kg, right.
kg for both, sir.
kg. Okay, so what is your G constant here now?
G constant is 6.67
G is known as 6.67
times 10 to the power of -11
times 10 to the power of -11
Newton meter square
Newton meter squared
per kg
Per
square.
kg squared. Good. So now,
Kg, sir.
oh sorry, kg. So now we'll substitute these three values here. So G is 6.67 times 10 to the power of -11. Your mass of proton, or mass of electron is 9.1 times 10 to the power of -1. And your mass of proton is 1.67 times 10 to the power of -27 and divided by
The distance.
distance. What is your distance? Is 4.3 times 10 to the power of -11 squared. So give me an answer using your calculator. Make sure you use your bracket properly. Otherwise you will totally get a different answer.
5.3
but still we are not yet to the final answer. It says find the magnitude. It means the ratio of electric force and the gravitational force. So we have now magnitude. So the ratio is equals to
Fe over Fg.
Fe divided by
Fg. Force of gravitation.
Fg. So your Fe is this value, 1.24 times 10 to the power of negative 7 Newton divided by
5.49
5.49 times
times 10 to the power negative 47.
negative 47 Newton, and your answer is
2.26 times 10 to the power
2.26
39.
times 10 to the power
39.
39.
39, so positive 39.
Positive 39
That's it.
Newton.
So no unit for
Ah, good. Because Newton and Newton, they cancel out. Okay, so thus the gravitational force between the charged atomic particle is negligible when compared to the electrical force. So on page number 90, there is 2 more example. So make sure you guys go back home and understand those examples. It's very simple, similar to this, but like just find electric force and all. And then on that same page 91, there are 3 questions given. So you make sure do that as your homework. Just a hint, 2 of those questions from the example and the exercise. So there's 5 questions you have to go and do at home, right? The 2 example and 3 from your exercise. 2 of those questions are in your midterm paper. So make sure you go home and do your question and example and understand them well, and in the next class we'll do those questions. Thank you. So any questions regarding anything we have learned today?
No, sir.
No? Okay, so we'll end our class here and I'll see you tomorrow.